Login accepted.
Dzień dobry. How are ya? Look at you wonderful people. I'm so glad we're all here together. It has been a long time for me. I have not been here, I don't know, it was before the COVID pandemic, right? A long time. Before COVID, or BC, right? Yeah. Too long. I'm so glad we're all here. Come on in. Have a seat. There's plenty of spots. Sort of. Come on in, have a seat. Who had a good lunch? Good lunch. All right, appreciate it. Who's had a great show so far, even though we're just in the first day? All right. Good stuff. Wow, I can't believe it. I'm not sure if it was 2019 or 2018 the last time I was here. I'm trying to remember, but it feels like yesterday, either way, although it's been half a decade, like a long time, way too long. I am so happy to be here with you all. So happy. Okay, well, we should get underway. Okay, my friends, look, as always, we have to take care of some very important things before we can actually start the discussion today. First and foremost, can we take a selfie? Oh, yeah. The very, very sort of lackluster conviction in that. But okay, great. Let's take a photo. It'll be great, okay? Everybody just pretend like you're happy. Here we go. Okay, ready, steady, say, open source. Oh, yeah. Thank you so much for that. I appreciate it. Come on in, everybody. Have a seat. This is a nice, big auditorium. Lots of spots in the front here. Appreciate it. I'm so excited. Thanks for that photo, or those photos. I'm going to take them. I'm going to show them to my daughter, and I will say, see, they listen to me. Okay. No, I appreciate you all here. My friends, my name is Josh Long. I work on the Spring team. As I said just a minute ago, I am so very, very happy to be back here. And it's a good thing, too, because there's a lot of time has passed, but not so much in the big picture, in the big scheme of things, not so much time. And frankly, with the passing of all that time, so many amazing things have happened, and yet I think that today, right now, at this era, at this moment in the software ecosystem and in the history of Java and Spring, I don't think that there has ever been a better time to be a Java and Spring developer. And so, friends, we're going to talk about that today. I want you to know I've only got an hour. I've got 46 minutes here with you today. But this conversation doesn't need to stop here. If you want to reach me via email, I'm on email. Who uses email? Email. Anybody? No. Moving on. Good. I am on the Bird website, if that isn't already on fire, and I am very embarrassingly a YouTuber now. So it's not going to be the worst mistake you make to like and subscribe. But anyway, yeah, I'm completely, utterly surprised and enamored by the current age in software. It's an amazing time, right? An amazing time to be a Java and Spring developer, and I say that fully aware. I understand. I was there for most of that time. I am fully aware of just how much has happened in that time. And to celebrate that, actually, here's this thing that we put together here, spring1.io, history of Spring. And it's a little game, right? You go here, use the arrows, you can move the character, and see the history of Spring. This year, 2024, for the people watching this video in 2040, we celebrate 20 years since 1.0 GA Spring Framework, okay? And then we celebrate also 10 years. Come on. Yeah. Nope. Fine. Moving on. Spring Framework 1.0 released. And then we go down here, and we celebrate also 10 years since Spring Boot 1.0. Here's 2014, GA. So 20 years of the GA versions of both 20 years for Spring Framework, 10 years for Spring Boot. And we're going to go up here, over here, into the clouds. I hope that's not too subtle. All right, look at that. Good stuff. Oh, yeah. Nice photo. Good stuff. So we're going to go into the clouds. And, Spring Cloud and Spring Cloud Task and all this good stuff, Spring Cloud Data Flow. Now we're going down into the water, maritime themes, Kubernetes. You get the idea. Spring Cloud Data Flow for Kubernetes, Spring Cloud Skipper, Spring Cloud Gateway for Kubernetes. And then here we are, 2022, and we start in the modern era, right? Spring Framework 6, Spring Boot 3.0. And so on. So it's just been an amazing journey. There's just so much that's happened. But right now, friends, it's, I think, the most amazing time. And so to demonstrate that, we're going to go, as always, to my second favorite place on the internet. My first favorite place, obviously, is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It is better than Disneyland. But if you have never been to production, you can begin your journey here at start.spring.io, and we're going to build a service. Now, friends, I'm going to name this. We have some questions that we have to answer. First of all, what do we want to name our service? I've decided I want to name this service Service. And the reason is because I'm amazing with names. Really good. Just the best. I get that from my father. When I was a small boy, we had a small white dog, and my father named him White Dog. A very, very good with names. Amazing with names. That said, my mom, she tells me all the time, she says, "You're very lucky that I named you." And I say, yeah, that's probably fair. Yeah, that's probably true. Yeah. Just imagine what the name would have been. It would be not good, right? So there's the service, but the question then is, what are we going to build, right? What are we trying to build? We've got the name for the service, but what are we going to build? And I thought, I want to show you something that pulls together all the cool stuff in the modern world right now, in the ecosystem that I'm seeing, that I care about. And I thought, what can I show you to bring all these themes together? And I thought about the old Spring Pet Clinic. How many of you have seen the Pet Clinic? It's an amazing app that demonstrates a lot of different moving parts together, and I thought we could revisit that, but it's a lot. There's a lot of stuff going on there, you know? I don't want to have to unwind all of that. So I thought, what about like a dog adoption thing, a pet or dog adoption thing. And I was like, oh, that's a great idea. Everybody likes dogs and cats and stuff, Who doesn't like dogs and cats and pets and all that? And yeah, I mean, I've got a dog. He's a terrible dog. The worst dog. I mean, just miserable. He's a little tyrant. He's a tiny tyrant, a furry fascist. He runs around the house. He leaves his little rubber duckies on the floor, and if you get near the rubber ducky, he takes your foot. Right? He's a bad dog, but we still love him because we think bad dogs deserve good homes. All dogs deserve good homes. And so I thought, well, yeah, we could do that. And this dog, my dog, he's just the worst. His name is Peanut, right? And Peanut, he reminds me of this other dog that I read about during the pandemic. I don't know if you saw this dog. This woman, she was trying to find a new home for her dog, and her dog is named Prancer. And this dog matches my dog, and I was really taken by this. She said, look, there's not a very big market for neurotic, man-hating, animal-hating, children-hating dogs that look like gremlins, right? And she said that Prancer, she continues, I am convinced at this point he is not a real dog, but more like a vessel for a traumatized Victorian child that now haunts our home. This is my dog, right? This is Peanut. I understand this dog. Bad dog, but also needs a home, right? And if you look at him, it's kind of fun, It's kind of cute. So I thought, wouldn't it be cool if we did like a dog adoption thing? And, you might be wondering, hey, why, Josh, do you keep that terrible, terrible dog, right? Well, first of all, like I said, all dogs, they need love. They need a good home. That's part one. Part two is ego. I'll just be honest with you, okay? It's ego. Because in my home, my partner and our daughter, they both speak 5 languages. I only speak 3.5. So if the dog was not there, I would be the stupidest in the house. It cannot be. I will not allow it. So we keep the dog, right? And the third reason that we keep that terrible, terrible dog is because, well, he is also really cute. right? Very cute guy. So his name is Peanut too. So I was thinking about him. Let's build a dog adoption thing, okay? So let's go back to here, start.spring.io, and we're going to build a service called service, and we're going to add some other things. We have to specify what version of Java do we want to use. Friends, we've got 3 versions of Java here, but only 2 valid choices. You see, to use Spring Framework 6 and Spring Boot 3.0, you must use Java 17 or later. But friends, I would never use Java 17, ever. It's a completely inappropriate choice in all circumstances, except when you're trying to jokingly show people what never to do, right? It is the wrong choice in every situation. So I would never select this, and I'm not even sure why we even have this anymore. Instead, friends, we must use one of these 2. Java 21 and later is an incredible release. In fact, it is, in my opinion, the single most important release of Java ever, right? They did some amazing things in Java 21 that I still, every day I find new value in what they have done here. And we're going to talk about some of those features today. But Java 21, suffice it to say, is technically superior in every way. It's faster, more robust, more syntax-rich, more performant, more operations-friendly, more efficient, more energy-efficient. It is also morally superior. You won't like the look of sadness and shame in your children's eyes when they see that you're using Java 17 in production. Don't do this. Be the change you want to see in the world. Do the right thing. Use Java 17 or later. Or Java 21 or later. So I'm going to use Java 21. That's fine. Then we have to add some dependencies. I'll add the GraalVM support. I'll add the web support. I'll add Spring Data JDBC. Here we go. I'm going to add the Docker Compose support. I'm going to add, the web support. I've got that. Got GraalVM, Data JDBC. And then, friends, at this point, we have, what else do we want to add? Well, I want some help in structuring my application, so I'll bring in Spring Modulith. And then, my friends, I want to make it so we have some smarts in our application. And so I need a database, right? And I can use a SQL database here. But I also want to do similarity searches. And this is something that is really useful in the context of AI. So I'm going to bring in OpenAI. Now, I can bring in Bedrock, right? I can bring in Gemini. I can bring in, what is the other one? Azure, OpenAI, I can do all this. I can also just bring in Olama and run offline, air-gapped, no internet, right? I can do all sorts of things here, but I'll just bring in this one. You can use whatever you want, okay? It's just saying there's an option there. And I want to do vector search with a PG vector, but of course I could use Qdrant, or I could use Milvus, or I could use Chroma, or I could use Neo4j, or Redis, or whatever, right? But I'm going to use PG vector, and I'll add that to my application. So there's my dependencies, friends. PG vector is really nice because it's Postgres plus it is a vector store. So here's my zip file. Let's open this up in the IDE. Now, friends, I asked on the Spring Initializer, I selected here a Docker Compose, right? And when I did that, it generated this Docker Compose file for me for PG vector. I can use that, it's fine, but I've already got a SQL database. I've got a PG vector database running already on my local machine. And so I'm not going to use the Spring Boot support here. I'm going to connect instead to the one I've already got. And we should take a look at that. Let's do that actually here. I'll go to application.properties, and I'll add the connection credentials here. JDBC, Postgres, QL, localhost, my database, okay? My database. And we'll say username equals my user, and then we'll say password equals secret. So now I've got a connection to the SQL database running on my local machine. I'll ask IntelliJ to connect me to it. It'll show up over here. And you can see that we've got this table called dog. So if I go to the dog table, at the very bottom, you can find our dog Prancer, right? And he's described as a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like gremlins, right? So there we go. We've got him. And the goal today is to build a system to help adopt poor Prancer, okay? So we've got this application. The first thing I want to do is I want to build support for working with to adopt a dog, right? And the question is, how do I build this? Where do I start? And friends, I want to grow this application eventually. And so I need to put this functionality in a namespace. And a question that often comes up is, how do I structure my code base? I'll tell you how you don't do it. Don't do it like Ruby on Rails. Do yourself a favor, right? Ask yourself this. Have you ever written code, and don't be shy, it's okay. We all did this once in college, okay? But have you ever written code where you have a package called models, and another one called controllers, and another one called services? Has anybody ever done that? Raise your hand. It's okay. It's okay. We're among friends. It's a safe space. It's a safe space. You're all terrible programmers. Just the worst. Worst people. No, but I kid, but also, you're terrible. Really, it's not good. So what I want to do is, don't do that, right? Think about what you have to do to make that work. Every type in your system has to be public. That goes against the grain of the privacy controls that Java gives you. It's not an opt-out feature, it's an opt-in feature. You have to add the word public to get everything to be public. There's a reason it's not the default, right? You should have things be nice and encapsulated in private, right? Public is something you should use very rarely, and I almost never do, right? This and one other class will be the only public thing that we create today. And so the question then is, if we shouldn't put things in packages by their role, controllers, models, services, repositories, whatever, how should we do it? Flip it 90 degrees, put them in packages by their feature. What do they provide to the system? And so this is architectural guidance, and we're going to use a project called Spring Modulith. Spring Modulith is like pair programming with the Spring team, not just for your configuration, as you do with Spring Boot, but for your architecture. So I'll create a package here called adoption, okay? And here we'll create a new class called dog controller, okay? And maybe I can get rid of that, okay? At controller, at response body, good. So I've got this controller, and this controller is going to allow me to create, to work with data related to dogs. So what does that type look like? It'll be a dog, integer ID, string name, string description, string owner, and local date of birth, okay? Now this is an entity. I'm using Spring Data, and by the way, I'm using records. I love records so much, right? It's just so good, and it's very important. Yes, thank you. It's so important to remember how nice this feature is. It supports it's one of 4 different features in Java 21 called data-oriented programming. So you have sealed types, you have records, you have pattern matching, you have smart switch expressions over here. So smart switch expressions. These things, if you take them all together, support a new kind of programming. Remember, historically in the world of Java, it has been very good at large monolithic code bases, but it's not so good in this new world where increasingly the way we introduce a new change into the system is not by creating a new specialization of an abstract type, but instead by creating new bits of data that we send from one boundary to another, from one component or system to another. And increasingly, this data is network data. It's coming from Kafka and RabbitMQ and GraphQL and RSocket and gRPC and whatever, right? And so these things are stringly type ad hoc network data. They're not specializations of deep hierarchies of types. So the language has to be better at supporting data, right? And these 4 things, if you take them together, they support that, right? So I don't want to spend too long on this, but you should definitely look up Brian Getz, right? Look at Brian Getz has an amazing discussion of these features in InfoQ from, I think, 2022, right? 2022, 2 years ago. Okay, so now I've got a record here. This is just the beginning of a whole bunch of cool possibilities. I'm going to create a repository here. It's going to extend the list of CRUD repository of dog of integer, okay? Okay, so this dog repository will help me work with the catalog of dogs, or the dogalog, okay? So we will use this to work with that inventory. And let's create a method here called adopt, okay? And we're going to have a, post mapping. Maybe we'll make this I don't have time to create a separate service, so we'll make this transactional. And I'll do adoptions dog ID, and we'll say path variable integer dog ID, and request body map of string owner, right? So we're going to send the name of the owner that should be adopting a given dog in the body of this request, okay? And in order to do that, I'll inject the dog repository, which is, by the way, very cute. Just think about what that means, like a repository of dogs, okay? So this dot repository dot repository dot find by ID dog ID, if present, dog, And we've got that, and then we go here. Okay. If present, then we're going to create a new dog and update our dog's owner status. So dog.id, dog.name, dog.description, and then dog.date of birth. Does that seem right? And dog.owner. So, and then the owner, of course, we get from this JSON data, right? So here's the name for the data. Good. There's our updated dog, and we're just going to write this to the repository. So this.repository.save end dog, updating the dog. Good. So now we've got a very simple flow here, right? So let's save this out. Var adopted, okay, and system adopted. Voila. Adopted. Okay, so we've adopted this dog. Good. Very, very, very simple. Let's go ahead and run this program and see what we get. Okay, so I'll go to the command line here. Curl x post h content hyphen type. Oh boy, it's weird typing at an angle like this. When you can't see it, but I'm typing like this. It's very special. Application JSON. Okay, and then the data. We'll send that in a second here. Okay, and then HTTP localhost 8080/adoptions. And remember, our dog, the dog that we're trying to adopt, his name is Prancer. He's over here in our database, in our Dogalog, and his ID is 45. Okay, so we say 45. Now, the data that we're going to send, we send here. Okay, so the name of the owner, of the new owner, is Josh. Okay, and we hit post. And then look, it says we've adopted dog ID 45, Prancer description, a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like gremlins. And the owner is now Josh. Hooray! Prancer has a home, right? Good stuff. Good, good. And so this is all pretty good, but we put this all in this package, right? This package called adoption. And this is just one module in the system, right? It's just one part of the system. And obviously there's going to be other things involved in this process, right? The process of finding and adopting a dog has a lot of other things that need to be involved. Let's say I have a kennel. A kennel is another service related to the kennel functionality. Who's going to clean the cage, prepare the paperwork? What about another service related to the veterinarian? The doctor that will give the dog his updated shots and prepare the paperwork and all that, right? So there's a lot of other parts of the system that need to be aware of the fact that we have just adopted Prancer. So one thing I could do is I could create a new package, let's say over here, called kennel, right? And then put a new service over here. And I could make this public, right? I could make it public, and then I could inject this into the other class. But this was a problem because now I've got this spaghetti, right? I've got all these dependencies coming into this package, right? And that creates a single funnel where everything gets involved, right? And so instead of doing that, since the kennel doesn't need to be they just need to know about what's happening. They don't need to be involved in actually making it happen, right? They just need to know, and they need to handle it and respond to the event, but they don't need to be involved in any particular way in this transaction or in this logical thing here, right? This is what it is. If other things want to do something in response to this, they can. And the way we can do that is with an event, right? So we can publish an event from this module to other modules in the system that allow them to respond, right? And this gets us to a very interesting question, which Martin Fowler answered a few years ago, which is, what do you mean by event-driven? This is a great blog from 2017 BC, or before COVID, okay? And he talks about a number of different patterns for event systems, right? Event notification is you use an event to tell another system about the fact of an event, okay? Not the details of the event. Then you've got event-carried state transfer. Here, you're not just telling other systems about the fact of the event, you're also providing the delta, the information in the event so that the other systems know what has changed as well, right? For example, the owner field for Prancer has been updated to be Josh, okay? And then if you understand that event-carried state transfer, if you understand that all the mutations in the system are the result of events, then it becomes logically obvious that if you have all the events and you replay all the events from beginning to end in the order that they were received, then you can arrive at the same system state again, right? So if you delete your Postgres, delete your Elasticsearch, delete your Redis cache, delete all this, but you replay all the events in the system, then you will have the exact same Elasticsearch index and the exact same Redis cache and the exact same Postgres database state as well. So that's called event sourcing. And there's some interesting implications in that, which is if you have all the events, then you can replay them and fix any systemic algorithmic problems, for example. You also have a really nice way to do auditing. And then, of course, in that example I just gave you, where you have an Elasticsearch search index and a Redis cache and whatever, it's also obvious that we don't have one single database. We have at least 2 or 3. So this means that there is no more a single place that I can write to update the entire system. There's different places to write versus read. If I want to do a full text search, I use the Elasticsearch index. If I want to do a cache, I read from Redis, right? So I'm reading from multiple places, and I'm writing to multiple places. And that's the insight behind this, CQRS, Command Query Responsibility Segregation. So I'm going to use events, but what you have to understand is that it starts small. We're just going to use events in the Spring framework using a very, very old type called the Spring Application Event Publisher. Who knew that Spring has had an event bus in the application context for like 20 years? Did you know that? This has been here forever. You can inject this. It's from 1.1.1, and you can publish messages to other components in the actual context as you wish. So let's do that here, okay? So I'll say publisher.publish event. Now, what event are we going to publish? Well, let's create a new public type. This is the only other one that's public. Dog adopted event, okay? And here I'll just make it a record, and maybe this will be event carried state transfer, so do dog ID and then string owner, okay? There you go. You can publish this event here. So new dog adopted event, and we say this is adopted.id, adopted.owner, okay? So we're publishing the event to anything else in the system that wants to know about it, okay? So we've got that. And now let's go back over here to our other microservice, our other service, make this transactional. And here, I'll create an event listener on dog adopted event, okay? And maybe I make this sleep a little, maybe it has an exception, okay? Good, like that. System out, dog adopted, good. And dog adopted event, voila. So there's my listener that's going to update its own internal state. Maybe because I got this event, I can kick off the process of preparing the paperwork, right? And maybe this takes a long time. So let's sleep for, let's say, 10 seconds, okay? Or maybe even 10 seconds, okay? So we're gonna do the dog adopted event, and we'll say stop. And then start, so you can kind of see how long this is going to take. So let's go ahead and restart that, and go to the command line here. Okay. And look, I hit enter, but it's not returning. I published this message, and yet the other components are taking their time, and I have to wait. I don't even know about what is happening. I'm a producer of an event, and yet I still have to wait for that thing to finish. So this isn't great. So then what happens then if I use @async? Well, now this will complete immediately, and it'll happen in a separate thread, but now it's in a different thread, and I have no way of guaranteeing that it gets finished in time, or that it eventually gets finished, right? So what I want is some way to make it async, but also have a way to make sure it gets processed in case there's a power outage or something like this. So I'm going to use a nice annotation from Spring Modulith called Application Module Listener. This is a @transactional, @async, @event listener, right? So here's an event listener as well. So these 3 annotations together give me most of what I want, but what I still need is some way to make sure I can recover missed messages. So I'll enable a feature in Spring Modulith to republish outstanding events on restart, and I'll use Spring Modulith to initialize some database schema, okay, to create a table to restore the missed messages. Okay, so if you go now here, refresh this table, you can see we've got an event publication table there, and it has nothing in it. So let's try reposting this. It returns immediately, and if we go here, it says completion date is null, but it does have the event. So now if we refresh, 5 seconds, should go. There you go, 10 seconds, now it's finished, refresh, there's the completion date. So it's capturing the message, the method, the event, and it's logging the start and the stop. Let's do another one. Curl refresh this again, and you can see it still has that. I'm going to kill the process. Goodbye, right? And so now if I go here, if I refresh, it's still not completed. I'll restart this, okay? And we're going to just wait 10 seconds, I guess. Come on, there you go. So there's the completion event. So it replayed the missed event and made sure that it got delivered to all the components. Obviously, this has some implications. You want to make sure that your event handlers are idempotent. That is to say, there is no undue observable side effects. Okay, so now we have a well-structured, decomposed service, but we still haven't solved the heart of the issue, have we? We haven't figured out how to help people find Prancer. I found Prancer because I knew about Prancer, right? But how is somebody else going to do that? I knew the ID. So what I'm going to do is I'm going to use Spring AI. How many of you have heard of Spring AI? Okay, well, you do now. So Spring AI is a project that we built to help people work with AI engineering patterns, right? It brings the whole ecosystem of AI to your Spring code. And so we're going to use the chat client, which is, it's like the web client or the REST client or the JDBC client. I'm a big fan. There's a reason I'm a big fan of this type. Big fan. Huge fan, okay? So I'm going to use the chat client here, and let's just ask it a question. And by the way, it's important to remember. I said it before, but I want to make sure we're on the same page. You don't have to use a cloud-hosted one. You can use something offline on your own data center like Ollama. So for example, I could go here, Ollama run Llama 3. This is like Docker. Ollama is like Docker. It'll run a model for you, and there's like thousands of models. So I'll do this. Okay, here we go. Come on. And I'll say, dear Singularity, it's very important to be polite. Very important. They will remember. I've seen the documentary called Terminator. I know what happens. Very important, okay? Dear Singularity, please write a story about the amazing Java and Spring developers in the beautiful city of Krakow. And please do so in the style of famed children's author Dr. Seuss. And then, how do you? Somebody tell me how to say Jinkuya. DZ. I. L. No. We're just going to do this. Thank you. Thanks. Actually, here, be polite, right? Cordially, Josh. Okay, so look, this would work completely offline, air-gapped, right? It's downloaded, it's open, it's free, you can use it. It's very, very good. So I'm going to use OpenAI, but don't think it's your only choice. Not even close. You can run this completely offline. So I'm going to use OpenAI. I'm going to use the chat client. And I will ask it, and by the way, did you see this? It created this amazing poem for us. Dear Josh, I'm delighted to say I've crafted a tale for you in most playful way about Java and Spring devs with skills so divine in Krakow's fair city where beauty is truly sublime. In the land of Poland where culture abounds, Krakow's programmers prospered with coding all around. Their passion for Java and Spring like a flame that did glow, guiding them through challenges their projects started to grow. It's amazing, right? Okay, so moving on, I'm going to ask our new chat client, I'm going to say, hey, client, here's my prompt, okay? My user prompt. So var user equals this, multi-line strings, right? Do you have any neurotic dogs, right? That's my question for it. And of course, what do you expect it to say? I expect it to say, huh? Like, why would it know that, right? Var response, okay? And system out response, here we go. Response, voila. Okay, so there's this. Let's go ahead and run this. All right. So we made a call to the AI, and it says, I'm sorry, I'm an AI, and I do not have any pets. Like, of course. So, okay, we get it. It doesn't understand what we're trying to do. So let's give it a system prompt to give it a way to think about its persona. Okay? So I'm going to use a system prompt here. Let me go get that. Cat desktop talk system prompt, bb copy. Paste that in there, and it says now, you are an AI-powered assistant to help people adopt a dog from adoption agencies, from an adoption agency named Springs Pet Emporium, with locations in Krakow, Singapore, Paris, London, and San Francisco. And then we instruct it. We say, if you don't know about the dogs housed at our particular stores, then return a disappointed response suggesting that we don't have any dogs available. Okay, so pretty straightforward. We're giving it a way to think about how it should interact with us. It's a system prompt. Okay, so let's restart this. Let's see what we get. Okay, and when we ask it again, this time it says, hey, I'm sorry, but we don't have any dogs available at the moment. If you have any other preferences or questions, feel free to ask. And if we run this again, we get, let's see, run it again. Look at that. I'm sorry, but we don't have any neurotic dogs available for adoption at Springs Pet Emporium. So it doesn't have the dog, but at least it thinks it should, right? At least it's acting like it should be able to help us, but it can't at the moment. So it's got a persona, okay? Now, let's connect it to our database. Our database is the dog repository, right? It's a SQL database. But LLMs, chat models, they don't use SQL databases. They use text. So the heart of all AI engineering right now is what you can do to take your data over there and put it in the text that you send to the LLM so that it can make a response informed by that data. Okay? That's called retrieval augmented generation, or RAG. And you might have heard about it, right? So I want to do that, but I don't want to give it access to the SQL database because there's too much there. I want to send only data that might be of relevance. So what I'm going to do is I'm going to put it in a vector store, our PG vector store that we looked at earlier. And vector stores are really powerful, right? Vector store. They do similarity searches, right? Fuzzy searches. And so you can use them for other things besides AI. We have a whole catalog of implementations here. So I've got 2 on the class path. So let's say, let's inject a dog repository as well. Voila. And we say dog repository that find all dot for each dog. And then we're going to write this to the vector store. So we're going to create a document with the data about it. Okay. Here we go. Good. And we say name, colon, like this. Description, colon, like that. Dot formatted, dog, dot name, dog, dot description. And then we need to provide metadata telling it telling us how to find the source dog if we get a match from this document, right? So this is the, what did I do wrong? Map.of. Oh, it's the wrong document. I don't want Java Swing. Oops. Okay, so that's this one, Spring AI document. And then we will write this to the vector store. So we go here, vector store, where's the vs dot add list dot of, passing in the document. Now, obviously, this is a document about dogs, so a document, okay? Here we go. Let's write that. So we're going to run this, and then we're going to connect it to our database in the chat client. We're going to tell it to query the vector store and give us the responses, and then put that in the query before we send it to the user. So let's configure our chat client over here with an advisor. Okay, new question answer advisor. We'll inject the vector store like that, and we'll say new question and answer advisor vector store. It's like AOP for your LLM vector store, and we're going to give it some default query. You can actually use a query language to say, okay, find only the dogs that are in the CRaC location, for example. So let's go ahead and run this, okay? Restart. And remember, we've got this table over here called vector store, but there's only 1 record in it right now. Now there's 6 records, right? Writing some more, hopefully. There's 9, right? It's a little bit slow. This is one of the reasons why, GPUs are so important, is because this kind of math, the quantization, the matrix multiplication is so important. And it's another reason why I'm so excited about the vector support in Java coming soon, okay? So what happened there? What happened? Yeah, something happened. Okay, get rid of that, drop. I'm using an embedding client that's coming from OpenAI. If I don't have a good result, if the service is down, then guess what? It fails. So I got to restart that again. It's the problem of doing AI demos on stage. Here we go. Come on. Please, sir. There's 14, 20. Oh, come on. 25, 30, 35, 39. So close. We just need 51. Please. Please. Okay, there we go. So there's that. Now let's see. We ran this. Let's go to our assistant. Got too many windows here. go to our assistant. It's saying we don't have any dogs available. Let's see. I think it might have a cached result or something. So if we go to here and comment this out so it doesn't run again, if false, and then I'll just delete the target directory. Okay, restart. Okay, here we go. Yes, we have a dog named Prancer who fits the description of being neurotic. They are available for adoption at your location. Ha! We found one, right? Prancer's got a home. We're so excited. Okay, good. So now you might be saying, hey, that's just a text, but maybe I want to pass that to an API, right? And so I can do that as well. I can create a dog adoption suggestion, right? And I can give it a name and a description, and I can ask it to give us that data in that form, okay? So instead of content, I can say entity dog adoption suggestion.class, okay? There's this. And by the way, I might also want to register it for reflection for native images, so let's restart this. Okay. There we go. We got a dog adoption suggestion for Prancer, a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like gremlins. So now we have an object we can deal with. It's not just free-form text. We can pass this around and work with it in our code. Friends, we have an application that does a lot. We have an assistant to help people find dogs. They can ask free-form text, and then we can use that to programmatically interface with that data. We're off to the races. We're doing good here. I think it's time to take this thing to production. And friends, there are several things that we care about here in production. First, I want to make this call to the network. Remember, I'm making a network call to the OpenAI. I want that to be as cheap as possible, right? Each time I make a network call, I have inputstream.read, and I'm doing blocking I/O. And if I have that in a MVC controller, a service, then of course I'm blocking a thread, right? Thread blocking is bad. It limits your scalability. It limits your ability to do the work, right? So I'm going to enable virtual threads. How many of you have heard about virtual threads? Amazing technology in Java 21. You can plug in your own virtual thread executor service if you want. By the way, I'm not going to initialize this anymore. I'm also going to disable the PG vector store because it's already initialized, so get rid of that as well. But you can enable virtual threads like this. Okay, that's easy. So that gives you much better scalability. And you might be wondering, okay, how much better scalability? Well, let's limit my threads to 16, okay? Just to take a quick side tour here, a little digression, and I'm going to borrow an example from my friend Cora Eberklade, okay? She's an amazing engineer, and she's got this great demo that I'm going to steal from her. So htbin, okay, controller, and we're going to inject the REST client here, okay, like that, inject that into the constructor, and I'm going to create an endpoint here. So delay, we're just going to call it delay, and return this. So you say return this dot client dot get dot URI https httpbin.org delay, and then you pass in a number of seconds, and let's just say 3, okay? And then you retrieve the body, and you get the string. So what I'm going to do is I'm going to get the data from that network service. This network service waits 3 seconds or 5 seconds or whatever you give it before it returns the response. So it's going to block, and we're going to be forced to wait for that blocking behavior, okay? So I'm going to create this endpoint. It's a Spring MVC controller, and then from there we'll make another network request to this other service. So let's go ahead and restart that. And now, we have to define the REST client itself, of course. Nope, REST client.builder.build, return builder.build, voila. And now we can restart. Okay, so we go. Hey, minus, let's say, 60, minus C for 20 concurrent requests, localhost 8080 / delay. So I'm going to make 60 requests to the local service, and it is going to call that other service. I've limited the number of threads in my Tomcat to have just 16 threads, right? I also enabled virtual threads here, right? I said virtual threads equals true. So these results are what we get if we have virtual threads and we have arbitrarily limited our number of threads. So we can see that the total time for all 60 requests was 13 seconds. The slowest was 5, and the average is 3.6, and the fastest was 3.1 seconds. Pretty good. That's with virtual threads. Now we go here and we say enabled false, restart, okay? And we go here, take 2, and now we'll wait for the response without the virtual threads enabled, okay? That is sure slow. Here we go. Come on. Do the thing. I hope the internet doesn't die right now. Okay, very good. So there's without virtual threads. Okay. So, there we go. Let's see what we got here. There you go. So the slowest is 2 seconds slower than the fastest. We got 4.5 seconds per 4.5 threads requests per second on that one, and 4.1 on this one. Oh, well, that's not so bad, but usually it's a lot worse. Usually this is like 20. If the Wi-Fi is not the issue, then this is usually closer to 20, and this is already very bad. The 99th percentile is really bad in this case. So having virtual threads gets you the work done faster. It does it with less threads. It does it so that each thread goes faster and gets the work done, and there's less contention. So it's an amazing, amazing thing. I always recommend enabling that. So the next thing I want to do is I want to make my application as fast as possible. And friends, here it's very worth understanding that Java is already very scalable and very fast. Here's a great blog from 2018 BC that asked the question, which programming languages use the least electricity? And here you can see that C for the energy is number 1 for machines, not for people. Definitely not for people, okay? Then we've got Rust, okay, great, doing good, zero cost abstractions, very nice. C++, tooey, disgusting, moving on, disgusting, moving on. We've got Ada, okay, and then we have Java, and that's 1.98. Call that 2, okay? So 1 to 2, right? Java is twice as inefficient. Then you've got these other languages. You've got Go, Away, you've got JavaScript and TypeScript. What? I don't understand how JavaScript is 4.4 and this is 5 times worse, right? You've got these disgusting languages, the less said about which the better, moving on. And then, my friends, you've got JRuby and Ruby. JRuby is Ruby in Java, and Ruby is Ruby in C, and yet JRuby is almost a third more energy efficient. So Java's already very energy efficient. It's also quite fast. So here's a great thing from earlier this year. My friend Gunnar Morling, fellow Java champion, he asked people to submit programs in this 1 billion row challenge, 1BRC, and he asked them to submit examples of how quickly they could parse 1 billion rows of weather station telemetry data. And so the results come back, you cannot use anything on the class path. The results that come back, 1.5 seconds, 13 gigabytes of text, right? Loaded, processed, analyzed, statistics, dumped out, and the program exits all in 1.5 seconds. So it's really, really fast. If anybody tells you it's not fast, they're lying to you, right? It's an amazingly fast language. That said, most of these are using GraalVM, right? This is using OpenJDK 1.8, very, very nice, but most of these are using GraalVM. I like GraalVM, so let's go ahead and turn our program into a GraalVM application as well. So we'll do this, -d, skip tests, p native, compile, and then we'll just let that run. And this is my least favorite part about GraalVM, is that it just takes forever. It just takes so long for the compilation to finish. And now I understand this famous XKCD cartoon. I get it now. The boss says, hey, get back to work. And these guys and gals are just goofing around, and they say, no, compiling. Oh, okay, keep going, right? Carry on. I get this joke now. I didn't want to get this joke. I thought this was just the C++ people. But no, this is us now, right? So fine, it's fine, but it's just very weird. And I get very bored. I get very bored because I'm sitting there waiting for the compiler to finish, and what am I going to do? It just takes forever. I stare at the ceiling, I stare out the window, I'm waiting and waiting and waiting, and eventually I hear music. When I get bored, I hear music in my head, like the music that you have in the lift when you're going upstairs or something, and it's a very long lift, so you just hear this very boring music. And I thought, gosh, wouldn't it be great if everybody could hear elevator music as well? So I went to Oracle, and I said, Oracle, please play elevator music during the native image compilation process. And I got this, and I said, I already hear elevator music while I do these long-running compilations. I'd just like everybody else to hear it too. Thank you in advance for your amazing work. I got some great responses. This person said, could you make it this elevator music? It's from the James Bond video game of the 1990s. This person said, we could have beeps like a microwave. That makes a lot of sense. My toaster, when my toaster's done, it goes ding. Why can't my compiler, right? Makes a lot of sense. And then I got this response, and this one is from Dr. Fabio Niephaus. Dr. Fabio Niephaus is a researcher on the GraalVM team at Oracle, and he said, "Thank you for your feature request, Josh. The problem with playing music during the compilation process is that it's just fixing the symptoms, and we are, and we've been and are still working on the cause, making GraalVM more efficient in terms of time, memory, and CPU consumption." Okay, go on. Anyway, I have prototyped a -- Josh Long mode. So, you click on this, and it would picture, you'd run the native image compiler, native image, -- Josh Long mode, hello world. And then you're like, well, I'm still hearing music. Why is there music? Okay, music brought to you by Josh Long. So now you know, but you're still waiting. You want something to look at. So then it would print that out, right? And I think that would be great. I think that'd be a great addition to the compiler. I don't know when it's going to get merged. Hopefully soon. What were we talking about? Oh, the GraalVM, right. Okay, that is very embarrassing. That finished several minutes ago. Okay, so here we go. Target, service, whoosh. Oh, what happened? Okay, 0.1 seconds. There's our dog. We have virtual threads, and most importantly, friends, we have this. Take that. That's the memory. So look at that in RAM. This is kilobytes, okay? So divide by 1,000. It's 129 megabytes for a web service that starts up in an order of magnitude faster than in the JRE. Go to CNN.com in Google Chrome. You can get it to go to 800 megabytes. One page, one Chrome, one tab, and it can go 800 megabytes. So our production scale web service with virtual threads, the AI, robustness, observability, and all that stuff is ready for production. It's an amazing, amazing time to be a Java and Spring developer. I believe that. Who believes that now too? Good stuff. Who learned something new today? All right, who had fun? All right, thank you. Dziękuję, everybody. Thank you so much.